Try these yourself before watching through the solution. I'm also going to talk through for each of these questions how to like what they actually look like. I don't think you need to do this for the exam, but it's good for this video to help your understanding. So we're just trying to identify the key things that are required in these answers. Make sure you've read it through. I think a description of the traveling salesman problem is useful. There are different variations of the traveling salesman problem, so does need to be exactly once, and we're looking for minimum cost, so make sure we get those. The exactly once constraint makes it very difficult because in fact that's possibly impossible, so it becomes a decision problem. Then we describe the problem, we talk about how do we start, we make sure we get this idea of considering things recursively, and very importantly we describe when do we backtrack, when do we prune the branch. So this is when we find we visited somewhere twice, and that's when we stop and backtrack. Okay, or we talk about how does this story end. We find that we've visited all nodes and returned to the start. Now with traveling salesman, there's a little bit of extra work to do because we're trying to find the best solution. So we record the cost, and then we need to say, well, subsequent paths need to be checked to see if the total cost exceeds that minimum, and we would stop. When I say stop, I mean we stop and backtrack if that happens. So let's work through this. These examples are always a bit risky, but we'll go with it. I'm going to add things in alphabetical order unless there's any other reason. So I start with S, then I'll go SA. I would record the cost as we're going along. I forgot to put a number here. Let's call it 3. Then we would go in fact, so we'd go SA has a cost of 3. Then we would go SAB has a cost of 6. Technically, we would then consider SABA again, but that would obviously be wrong. Then we would go SAB. The next one I'll consider is D in alphabetical order, so that would be 3. From there we go SAB D E, which has cost. I forgot to add that, didn't I? So that would be 9. 9 plus 6 is 15. Then from E we would consider going to A. SAB D E A has a cost of 31, but we would prune that branch because we've already visited A. So from here we go SAB D E C. So 15 plus 8 is 23. From C we can only go to A. So it's always difficult to know how these trees are going to turn out, isn't it? We'll go this way. SAB D E C A. So that gives us 27. From here, technically, we would consider B next if we're going in alphabetical order. So we'd go B, then we would go E, and then finally we would go to S. So SAB D E C A S, which has a total cost of 30. When I make these videos, I'd be very surprised I haven't stuffed something up at this point, but here we have one solution. So we would store that answer at 30. Then we need to backtrack and look for other options. Well, if I'm for this one, we've already considered all the options. When we were at A, we could go to B, E, or S, so there's nowhere else here. Let's go back to this one. When we were at C, we could have gone to A, we could have gone to E, but that would have given us a dead end. So, I mean, we can put that here just for completeness. We find that one stops. Then we would backtrack to this one. So this is when we're at E. Here, we would have to consider D, technically. I mean, there's going to be all of these where you go back to the previous neighbor and you prune that straight away. And that kind of suggests there's room for a heuristic in there to make things a little bit faster. But yeah, hopefully this gives you an idea of how you would go back. And eventually, I don't know if it will be possible with this graph, but it might be that we backtrack and we get to this point here. And instead of going SA, we go, so we'd be out here, wouldn't we? We'd be like SB. And we would start there and we would find that's 2, and then we'd follow the whole process down. Again, you can see, I mean, this might be slightly better than just generating all possible answers, but it's still a very long-winded process.